Hello again. In this video, we're going to go over another related rates problem. So let's look at example 2. It says two small planes approach an airport. One flying due west at 120 miles an hour, which would be this plane. The other flying due north at 150 miles an hour, which would be this plane. Assuming they fly at the same constant elevation, how fast is the distance between the planes changing, which would be this distance here, when the westbound plane is 180 miles from the airport, and the northbound plane is 225 miles from the airport. Okay, so the first thing you should do in this problem is maybe draw a little sketch like the one they have here. So this is the westbound plane. Its distance from the airport we're going to call x, and x is a function of time, because this distance is changing over time. And then the distance northbound plane is from the airport, we're going to call y, and it's also a function of time. And then the distance between the two planes is z, which is also a function of time. Okay, so the next thing we're going to do is we're going to look at all the rates that are given, the rates of change that are given, and the ones we're trying to find. So we're told that the westbound plane is traveling at 120 miles an hour, which is a rate of change. In fact, it's the rate of change in x over time. So it's dx dt. It's also a negative number. The reason it's negative is because the distance between the plane and the airport is getting smaller as time increases. So there's a reduction in the distance as time is getting larger. Okay. The plane flying north at 150 miles an hour, that's also a rate of change. That's the rate of change in y over time, so that's dy dt. And it's also a negative number because the distance, again, is decreasing as time increases. The distance between the plane and the airport is getting smaller as time increases. So both of these rates of change are negative. And the rate of change that we're trying to find is the rate of change in the distance between the two planes, which is z. So the rate of change in z would be dz dt. Okay, so let's work out this problem. So again, when you have a related rates problem, write down the rates that are given, right? These are the two that are given, dx dt and dy dt. And then the one we're trying to solve for is dz dt. In fact, we're solving for dz dt right when x is 180 and y is 225. Right? The westbound plane is 180 miles from the airport, and when the northbound plane is 225 miles from the airport. So this is the derivative we're trying to find, right? Evaluated at x equals 180 and y equals 225. Okay, this is the foundational equation that we're going to start with. That just comes from the Pythagorean theorem. X squared plus y squared is equal to z squared because we have a right triangle. Okay, now we're going to take the derivative of this equation with respect to t on both sides. Okay, of course, this derivative you can find by finding the derivative of the first one and adding it to the derivative of the second one. Because you're allowed to break up the derivative operator across addition. Okay, now to find this derivative, we're going to have to use the chain rule because x is a function of time. But we're not given that what it's equal to in terms of t. We just know it's a function of time, but we're not told exactly what it's equal to. So you need to think of x as an inner function that depends on time, but we don't really know what it's equal to in terms of time. But you still need to think of it as an inner function. It's being squared, and squaring it is the outer function. Okay, so we're going to have to use the chain rule to find the derivative. Okay, so the outer derivative is going to be 2x to the first. The 2 comes down, we subtract 1. And then the inner derivative is just going to be the derivative of x with respect to time. Okay, and the same thing's going to happen here. The outer derivative here would be 2y to the first, and then dy dt. Again, using the chain rule, right? Your outer derivative times your inner derivative. Then the same thing's going to happen here. You're going to get 2z to the first, and then dz dt. Again, using the chain rule. Okay, so now we have to solve for dz dt. So we can divide everything by 2. Let's divide both sides by 2. That's just going to leave us with x dx dt plus y dy dt. And that's going to be equal to z times dz dt. And then we can divide both sides by z. In fact, let's just divide both sides by 2z. And that way the z's will cancel out on this right-hand side, and we'll be left with a z on the left-hand side. Okay, so now we have dz dt by itself. Now we want to evaluate this. X is 180 and y is 225. Okay, so let's evaluate dz dt when x is 180 and y is 225. Okay, so we've got to plug 180 in for x. Then dx dt is negative 120 plus y is 225. Then dy dt, which is negative 150. And then all of that is divided by z, which we haven't solved for. We know x and we know y, but we don't know z. Now, we can solve for it because we know x squared plus y squared is equal to z squared, and we know both x and y. And so let's just go and find that. So 180 squared, x squared, plus y squared, has to equal z squared. And then we can take the square root of this. Technically, when you take the square root of both sides of this equation, you get plus or minus, but this is going to represent a distance. So we know it has to be a plus. Okay, and so if you just plug that into your calculator, you'll find that z is equal to 288.1 miles. That's where that comes from. And that's rounded off. So this is going to be an approximation. Okay, and then if you just plug this into your calculator, you'll find that dz dt is negative 192.1. And that's going to be in miles per hour, which matches the derivative. Z is measured in miles because it's a distance, and t is measured in hours because it's a time. Okay, so this is the rate of change in the distance between the two planes right when this airplane is 180 miles from the airport and this plane is 225 miles from the airport. So the rate of change in the distance between these two planes right at that moment in time is it's 192.1 miles per hour, and the negative indicates that the distance between the planes is decreasing as time increases, okay, which it obviously is, right? This distance is going to decrease as time gets larger because both of these planes are getting closer to the airport, and therefore this distance is getting smaller. Okay, so I hope you found this video helpful. Thank you for watching. Bye-bye.